All right, so 6.4, we are going to be dividing polynomials. There are two different ways to divide polynomials. I'm going to teach you the long way first. It's called long division. And then there are certain cases. We cannot always do the shortcut, but there are certain cases where we want to cut down the amount of work, and we can do something which is called synthetic division. So I'm first going to show you the long way, and then we'll do the shortcut way that works in certain situations. Now, long division, it's probably been a while, right, guys? If I were to write this problem up on the board, is this the way that you guys learned long division?
Yep.
Okay, good. I'm just waiting for the next generation of students to come up and be like, nope, we don't do it that way. So let's do a little refresher about how we do long division. I have 37. Does 37 go into 24?
No.
No. So I've got to go one more out, right? How many times does 37 divide into 240?
6.
6, thank you. I then multiply my 6 times my 37.
204.
It's 222.
I got 222 as well. Then, right, here's the big leap, right? We multiplied and got a positive number, but I have to subtract to see what is left over for me to figure out. So I get my 18. I then bring down my extra number, right? Because this number here should not be divisible by 37. That's why you have to bring down another placeholder to be able to do that division. So how many times does 37 go into 186? 5. Right, now just pick up my calculator and figure it out. 5 times 37, 185. I do my subtraction, right? I change it from a positive to a negative, and I subtract, and I get down to 1. No, we are not going into the decimal land, right? Putting a 0.0, and we're not doing that.
Oh.
But what does this represent here?
Your remainder.
Your remainder, okay? So the way that we would probably write a remainder in class, right, is we would just, when you're in middle school, or I don't know when they learn this, to be honest, what grade level, we would just write a remainder of 1. Well, I'm going to have us be a little bit more strategic, because what this really means is I have 65 and 1/37 left over. We are going to do this exact same process, but we're going to throw in x squared. But it's the exact same process. We see how many we can get here, and then we'll subtract. So just holler at me if I go too fast, because this is one of those things, right? We don't have that many problems to do as practice, because these problems can get pretty lengthy. Let's look at our first example. We've got a polynomial, and we're dividing by x plus 3. So I'm going to set it up the same way I did with that previous question. I'm going to write it all out. I'm going to divide by my x plus 3. Now here's the thing. If you are missing a placeholder, you must put in a 0. Right? If I have 306 divided by 9, I wouldn't write it as 36, right? I have to have a placeholder. How many are in the tens place? So you have to do the same thing here, except instead of it being the ones, hundreds, tens place, it's going to be the constant, the x squared, the x cubed, the x fourth, however it keeps going. So here's what I want. I want, when I put something up here, and I multiply it by x plus 3, I want to get rid of this x cubed. So I need to put whatever number up here is going to give me exactly an x cubed up front. So what can I multiply x plus 3 by to get x cubed? X squared. I multiply my x squared. Now when I do this, right, I have to multiply both parts. So I get x squared times x cubed, x squared times 3 plus 3x squared. questions so far? All right. Now, what did we do when we did long division? Did we add these?
Subtract
No,
them.
we need to subtract them. So when I subtract, I need to change my signs to be the opposite of what they are right now. Now here is where I combine these together. My x cubed minus my x cubes go away. That's exactly what I was looking for. Now 2x squared minus 3x squared is negative 1x squared, or negative x squared. I then bring the next term down, right? That's my next placeholder. All right, the next thing I'm going to put up here is, okay, I want to get exactly a negative x squared. So what do I need to multiply x plus 3 by to start out with a negative x squared? Negative x. Usually the signs are the things that trip students up the most. So I multiply my negative x times x, negative x squared, negative x times 3, minus 3x. I then change my signs, right? I'm going to be subtracting this, which if I subtract this, right, it's going to wind up changing my sign. So now this is a positive x squared, and this is a positive 3x. I combine these together. My x squareds cancel out just like I wanted. Negative 6x plus 3x is negative 3x. Bring down my negative 9. What do I now need to put up here to get exactly negative 3x?
Positive 3.
Negative 3.
Negative 3.
Ah.
I know. It's almost like I'm asking you to forget future steps and just think about this step itself. So I get a negative 3x and a negative 9. And I go ahead and I change my signs because I'm going to be subtracting both of these terms. So they both become positive. Add them up. What do I get?
0.
I have no remainder. This divides perfectly. So let's talk big picture for a second, because I know you're probably wondering, why are we learning this, right? We're just trying to find x-intercepts. If I get a remainder of 0, that means that x plus 3 is a factor of my original polynomial. So that's a really good thing. You will do this a little bit in this unit, right? We'll have one section over it. You'll have a question or two on your test. You do a lot of this in pre-cal, and it really is just a practicing your algebraic skills. All right, let's do another one. So obviously I put this one in here right away. What term am I missing?
X cubed. Not cubed, squared.
I'm missing an x squared. So as I set up this problem, I'm going to put in a 0 x squared. And I'm dividing by this whole thing. X squared minus 2x plus 2. Make sure I don't run out of room. Okay. I want a 2x to the 4th. So what do I need to multiply by to get that? 2x squared. Now what I like to do to kind of keep everything in line, just like we would with the 1s, 10s, 100 place, I put the 2x squared over kind of my x squared column. It's going to help me to stay organized. I definitely recommend it. So I multiply my 2x squared by all 3 of my terms. I get 2x to the 4th minus 4x cubed plus 4x squared. I'm subtracting this, so I'm going to go ahead and change all of my signs. My x to the fourth nicely cancel out. I get 7x cubed minus 4x squared. And I bring down my next term, 5x. All right, what is my next one?
7x.
7x. I want exactly 7x cubed, so I need a positive 7x up here. That's 7x cubed minus 14x squared plus 14x. I'm subtracting this out, so I'm going to go ahead and change all of my signs. And I will end up with 10x squared minus 9x. Bring down my final term, negative 1. All right, what's my last number? 10. I need a 10, right? I need to get exactly 10x squared minus 20x plus 20. Change all of my signs. And I wind up with 11x minus 21. So is this here, this x squared minus 2x plus 2, a factor of what we started with? It's not. But when I did this division, so here's how I would kind of recommend you write the solutions. You write 2x squared plus 7x plus 10, and then your remainder all over what you started dividing by. Just like we did with our long division example. What do you think? I know. It's definitely your process. Do you want to try the next one on your own or do it together?
Alone.
Alone? Okay, I'll get you guys started and then I will slowly start adding up the answer on the board. But let's see how you do on your own. Question for me?
So wait, do you just like how did you get like at the very beginning, how did you get like 2x squared at the very top? Like for your solution?
I want this.
So did you just multiply it?
I have to figure out what would I multiply this by to get exactly 2x to the fourth to be my first term. Okay? Then when I go ahead and change it to a subtraction, it's going to go away. Like I'm trying to slowly eliminate each one of my biggest exponents as I go.
Okay.
But it is. I recommend thinking, okay, what do I need to multiply by to get exactly this first term? I don't care about the rest of the stuff. Just this first term. Now subtract it and make sure it really does cancel out. Everybody found the missing term, right? I do not do this with the regular class. So I know I'm asking a lot.
This is a process.
It is indeed. Is everybody ready to learn the shortcut, probably?
Oh,
When I can easily learn how to do it, it's just tedious having to go through all of the work.
It is
and
extremely
if you make a
tedious.
small mistake, you mess up everything else.
I completely agree. That's why I keep checking my notes as I do this. Last thing I want to do is make a mistake.
Ugh.
I'm probably gonna forget how to do all of this next
No,
class.
you're not. Unless you want me to keep assigning more practice.
No.
Okay.
Why is it snowing?
Yeah.
Who asked for this? Yeah. Who asked for the snow?
Me?
They had said that it wasn't gonna stick. We'll see. We'll see if they're right.
Sure.
We'll see.
What does stick mean? Like it won't clump together?
Like it won't stick to the ground.
Oh, it's It'll stick to the rest of the snow, but it
It'll
won't
stick to everywhere.
stick to everything else.
All right. So is this a factor of our quark? It's not. I didn't get a remainder of 0. I got a very complex remainder with it. So this is not a factor of my polynomial. All right, you guys ready to learn? Do you want to do example 4 together, or are you ready to learn the shortcut?
Shortcut.
That's shortcut. The reason I say that is because we could even use the shortcut on this one. So that's why I want us to learn the shortcut. So when can you use the shortcut? It can only be used if you are dividing by either x plus some number or x minus some number. So if you're dividing by not an x squared, not an x cubed, anything like that, if you're just dividing by x plus 3, x plus 1, x minus 4, anything like that, you can use the shortcut. And you guys have seen this shortcut already.
Mm-hmm.
We did it at the very beginning of the unit. So here's how it works. You guys kind of remember this little half rectangle? Yep. We're going to write down just the coefficients, and if I'm missing any coefficients for any term, I have to put in a placeholder of a 0. So I've got 1, 2, -6, -9. Now here is kind of the tricky part, because I know we're ready to get going, right? X plus 3. If this was a solution, if this was a factor of my polynomial, what would be the solution? Harder. -3. That is what you have to put here. You have to put the opposite because we're trying to figure out, is this a solution or not? If we get a remainder of 0, then yes, it will be our solution. So as a refresher, we did this, we called it synthetic substitution. This is called synthetic division. It has the same process. I bring the first number down, I multiply, and then I add. I'm always adding down the column. So 2 minus 3, -1. -3, -1. +3. -6 plus 3, -3. -3 times -3 is 9. Add those together, 0. All right, so now that we have all this information, what does this mean? Okay? The very last number here, that is your remainder.
Ah.
So I have a remainder of 0. So that tells me this is a factor of this cubic, right? We could have factored this by grouping and figured it out.
So are we gonna have to also find like the answer to it then?
Yes. So where is the answer, right? It's hidden in here somewhere. We're going to start from the right and move over here. The first number here, that's your constant. The next placeholder up, that's your x's. The next placeholder up, that's your x squareds, right? And we can keep going up because we've lined these up in order from our biggest exponent down. This is now just one less exponent. So when I divide this polynomial by this polynomial, my solution, or my answer, is x squared minus 1x minus 3.
So then if it had a remainder, would you have it as?
You would then
whatever
write
number
it the
over?
same way, right? We would say I got a remainder of 4, we would say 4 over x plus 3, because that's what we were dividing by. Good question. All right, let's try the shortcut, right? We're dividing by x plus 1, so we can do the exact same thing down here. Am I missing any coefficients?
Yes.
X. So I've got 4, 5, 2, 0, 1. And the number that I put on the outside here, -1. Don't forget that, right? We want to figure out what is the 0, what is the solution to that. Bring down my 4, -4, 5 minus 4, 1, -1, 2 minus 1, 1, -1. Just want to make sure. All right, did everybody get a remainder of 2 on this one? So is x plus 1 a factor of this polynomial?
No.
No, it is not. But when I divide these two polynomials, I get 4x cubed plus x squared plus x minus 1 and a remainder of 2 over x plus 1, right? Because that's what I was really dividing by x plus 1. I put the -1 over here because that's the process for using this shortcut. All right. So the next thing in your notes is this kind of table, which I know it's like I'm just drilling this into your head. I'm bringing this up all the time, right? I guess what I want to make sure that you understand is even if you're having trouble figuring out the factors, if you know your x-intercepts, right? If you can look at a graph and see your x-intercepts, you will know your zeros. You will know your solutions, right? These two mean the exact same thing. So if x plus 1 and x minus 5 are my factors, what are my zeros and solutions?
5 and -1.
5 and -1, right? In whatever order you want. They mean the exact same thing. So if I know my zeros are 7 and 3, those are the same things as my solutions, what would my factors have to be? X minus 7, x minus 3. Right, and if I wanted to FOIL and get the whole quadratic out of there, I could. Right, looking at this part of the table, what are my 3 zeros?
0, -4, and -2.
Exactly. And in my last example here, right, these two things mean the same thing. What are my factors?
X plus 8, x minus 8.
Yep. So now that, right, we've kind of drilled this into your head so much, I'm hoping that everybody in this room understands you can go backwards. That is something that can definitely help you on an ACT, right? If they show you a picture of some kind of polynomial and you can see the x-intercepts right away, you can figure out what the function is. You might have to do some multiplying and FOILing and combining like terms, but you know all these answers. All right. So the final thing we're going to do, definitely we're going to keep going, right? What happens if we get a remainder of 0? We know that whatever we divided by was a factor. So I'm going to have you guys go an extra step. All right, if we get a remainder of 0, whatever you have left over, see if you can keep factoring it. See if you can find all of the zeros, all of the solutions.
Oh,
I know. Don't worry, we'll do it with the shortcut method, right? We're dividing by x minus 3. I want to figure out if I get a remainder of 0, right? Probably you guys realize at this point we should get a remainder of 0. And I'm going to divide my polynomial by x minus 3, which means I will have a 3, a positive 3, on the outside. Doesn't look like I'm missing any coefficients. Go ahead. 3 times 2, 6. -15. So when I divide this polynomial by x minus 3, I'm left over with 2x squared minus 5x minus 12. Right, so I started with this cubic polynomial, which we probably could have factored, right, very easily if we use grouping. And now I'm down to x minus 3 and this factor here. These two things, right, your cubic equation and this are equivalent. Can this factor down?
Well, actually, you could.
Technically not, because the only factors of 12 are 6 and 2,
3 and 4,
3 and 4, and
12 and 1.
and they don't equal up to 5.
But you got this 2 out front. It's not a 1x squared.
Oh yeah.
So you might have to guess and check or do grouping.
Sick.
All right. They need to multiply to give me a 2x squared. 2x and x.
Right.
Now this negative sign in the back tells me they're going to have different signs. So I really don't know where to put a plus, where to put a negative. And I've got all these different factor pairs to consider. See if you see it.
6 and 2. 3 and 4.
Which one, it's 3 and 4. Which one goes where? Which one's positive, which one's negative? Right?
Don't we say it?
Yeah, go ahead.
Okay, it'd be 2x plus 3 and x minus 4.
Perfect. So, once we get all the way down to here, right, we know you're going to have an x-intercept at x equals 3. We already showed that by having a remainder of 0. Now, your other x-intercepts are negative 3/2 and 4. And we could do that because we were able to get a remainder of 0.
What's the 3, 4, 6, 2, 12?
The factor pairs of 12.
Oh,
That's
okay.
what has to go in the back here.
Okay.
Yep, so I was just, these are all the things we have to guess and check our way through. Yep, Clayton?
So if you did have a remainder, would you not be able to factor?
You would not have to keep going. Nope. Mhm. It really is just right. I'm trying to make sure we make that connection between what we're doing up here and how it works in the big picture. Because every question that you guys will probably get on a test, you know how to factor with all your other ways of factoring. So you don't necessarily have to do this process to factor. But as you take more advanced math classes, and these are not x cubes anymore, maybe they're x to the 7th or 8th or whatnot, you can use this method to continually drill down to find all of your x-intercepts. All right, that's all I have. You guys have a good amount of time to work on 6.4.
Well,
I have no other, unless you guys want to do an ISL, but I figure maybe it's just time to do some. I'll go around.
I did corrections. Am I able to just pen send that?
Yeah, go right ahead. Go for it. There you go.
Oh, so
That's right.
X is
Now
nine.
plug in x into each of those dimensions.
Like that?
Yes, 8 and 6 and 9 are your 3 dimensions. Yep.
So that's the answer?
Go for a problem.
This is
That's it. Perfect. Now find the dimensions.
Oh, plug it in.
Plug in for x. Yep, you got it.
Oh, okay.
Go for it.
Remember, I like in these two.
Yep, that was going to be imaginary. That was the
Can we use when it says use long division, can we do the little shortcut thing?
No, if it says use long division, use long division. I was just trying not to give you too challenging a problem.
So this one right here and
Just to
this
practice
one
the process.
here. This one and this one I didn't do because I didn't do it. Like my combination for it.
Okay. Well, you need to know how to do it. You want to do it?
Yeah.
Okay.
It just gets worse every
Get out
time
your
I go over.
calculator, turn diagnostics on.
So is that my answer? Do I have to solve for it?
Yep, that's it. Those are your 3 dimensions.
Thank you.
Yep.
Why not? Go ahead, no